GT is a fantastic package to create beautiful tables in R. And the nice thing about this package is that it is also a framework that transcends programming languages. You see, in Python there's also great tables, which is the same thing but in Python. So in this and the next video we are going to create this table from R first and then from within Python. And you will see that if you can do it in one language, you can do it in the other language as well, as the syntax is nearly identical because the framework is the same. So with that said, let's dive in. In my Quarto file, I've already set up a code chunk that loads the tidyverse and GT and also includes the dataset via a CSV file. If you load the dataset, you will see that you get a table that has 14 rows and 7 columns, and this is the data that basically corresponds to the table that we want to create. This data originally comes from the Tidy2 state challenge, and I will link to the original dataset in the description of this video. But here for this video, I've already done all the pre-processing separately and only extracted the data that we need for the table into a CSV file so that we can focus on the table itself. But if you look at the dataset, you will realize that there is no information about images. So that's why we have to figure out where to get the images from that we have seen in our original table. And for the lines, that's pretty easy. I've already set up a directory inside of my working directory where all of the line charts are included for each of the stock symbols. You can create such a line chart with any plotting tool you want. For this I've used ggplot, but again you can use whatever tool you want. And to get the logos of the companies, we will make use of a fantastic GitHub repository from Tanya Shapiro, who has collected a lot of PNG files for all of the companies inside of this repository. In case you don't know Tanya, she is a freelancer and she works in the space of data visualization and she's doing fantastic work there. So check out her work if you're interested in that. I will put a link in the description of this video. And as for the logos, we can see here that all of the PNG files are named according to the stock symbol of a different company. And if you click on one, you can immediately see, in this case, the Apple logo. And if you open that, you will see that the URL for this specific image is just this path here, followed by the stock symbol.png. So we can make use of that by copying this as our base URL and then appending the corresponding stock symbols after this in our dataset. So let's do that now. In RStudio, we can first minimize our files pane here, and then we can save a variable, let's call it base URL, and in there we stick in the part that is the same for all of the images. And now we can modify our dataset using the mutate function, where we create a new column which we call logo, and in there we have to insert a string using the glue function, and that string will consist out of image tags, which are HTML notation for including images inside of HTML. And we can use that to get images into our table, and we just have to specify things like the height in pixels inside of the image tag, and we also have to set the source for the images, and that is the base URL we have specified here, followed by the stock symbol that we have in our dataset, followed by the file extension .png. So here we make use of the glue function, which can insert variables into strings, and if we execute this, we see that we get an error because I have to execute this whole code chunk, and now we see that we have a new column which is logo. So let's just use the select function to get the stock symbol and the logo, and now we can see that inside of this column we always have this image tag in there, and if we wanted we could also pull the logo column to see that each entry really uses a different image as a source file. So now that we have that, we can remove this pull here and we can replace the stock symbol column with another link via image tags to some source on our local file system. Namely, we can link to all of these images that contain the lines for each of the stock symbols. The logic for that is pretty much the same. Inside of the mutate call, you override the stock symbol column using the glue function that will throw the image tags, and in there you specify the height of 50 pixels again, and you set the source to something on your file system, namely the lines directory where all the images are stored in, and then you append the stock symbol to that path and you add the file extension to this. And if we execute this now, you can see that inside of the stock symbol column, you have different sources for the different images that you want to use. So that's how you can understand how to get images into your data set. So let's remove the select part here to get back all of our data here. And what we could also check now is to have a look at the company column. And we see here that there are a lot of weird abbreviations inside of these names. And there's also a very long name like International Business Machines Corporations, which is IBM. And we don't really want to have these weird abbreviations or long-winded names inside of our table. So this is why we can easily clean up these labels, and then we're done with the housekeeping and we can just focus on the table. So bear with me here as I throw in the code that cleans up this company column. I will go over this quickly here, but if you want to have more details on that, let me know in the comments and I'm happy to give you more details on that in a separate video. So what we can do first is to use mutate to override the company column. And first we're going to check if in the stock symbol we have IBM, because that's the stock symbol for International Business Machines Corporation. And in that case, we want to have the company column be just IBM. And in all the other cases, the company name should stay as it is. And that way we have cleaned up this one particular row. And now we can remove all of the weird unnecessary things like .inc, Cisco Systems, .com, and all of that can happen by overwriting the company column again. And here we use the string remove function. And here we remove commas followed by .inc. In case you're not familiar with these notations, these are regular expressions. And again, I don't want to go into too many details in this video, but it will just remove all of these comma.incs here. And this is also something I will cover in my upcoming data cleaning masterclass. If you're interested in information about that, I will put a link into the description. And if you do that, you can see that all of the inc abbreviations are gone. And similarly, you can remove words like corporation, platforms, or systems. And that way you have cleaned up the column even more. And finally, you can remove the .com in Amazon.com. And now you have nice, clean company names for your table. And with that, you can remove this select call here and you have the complete data set again. So now all that's left to do is to rearrange the columns so that they are in the order that they appear in the final table. So this means that we just use the select function, and in there we can first select the logo, then the company, the opening prices, the change in absolute terms, then in relative terms, and then we use the stock symbol because that's where the line chart information is stored in. So with that, we've just rearranged our data a little bit, but that's the data we need to create our table. So let's save this into a variable and call it df_cleaned. And with that, we have everything we need to create a nice table. So let's create a new code chunk for this. And the nice thing about the GT package is that it's super easy to start. You just take your data set and pass it to the GT function. Of course, this doesn't look particularly nice out of the box. And you can see here that the images are not actually images. They are still this weird long text that we put into our data set. In the Python version of this package, it's actually nice because, as you will see next week, you don't have to change anything. The images will be displayed out of the box. But in the R version, you have to format the image columns using the format markdown function. So this means that you take your GT table and pass it to the format markdown function and target the columns, logo, and stock symbol. And that way, markdown notation will be enabled for these two columns, which also includes the proper rendering of HTML text like the image tags. So if you execute this, you will immediately see that now you have nice images inside of your table. So with this one step, you've also fundamentally understood how to create nice tables with GT, and that is by passing the table thingy to subsequent layers from the GT package that modifies the whole table according to your wishes. One such function that you could use next is the tab spanner function, which allows you to create column labels for multiple columns. For example, you can combine a label for the opening prices and for the changes. So that's why you pass this to tab spanner and then you specify the label that you want. You could use markdown notation in those labels as well, using the MD or markdown notation in there. And that way you could make bold text using the typical markdown notation with these two asterisks. And in between, you just stick in the things that you want to have bold. Here we use opening prices, and the columns that correspond to that are the columns open 2020 and open 2022. So these are the original column names that you have inside of your table right now. But even if you were to change these labels inside of the table, you can always refer to the original data set and its original column names. So in that code that you have here, you can always use the original column names, even if you have different labels here, which we'll also do later on. So if you execute this, you can immediately see that you get a nice tab spanner that spans these two columns. And via a similar logic, you can use the tab spanner function again, use as a new label the change, and the columns that you need to target there are the change apps and the change rel columns. And that way you get a nice tab spanner that spans these two columns. And now that you understood that you will always refer to the original column names, we can also change the column names that appear in the final table. So that's why we pass everything to the calls label function, and in there we just have to specify for each original column name the new column name that is supposed to be displayed in the table. And that's how you can just make a list, basically giving a name for each of the columns that you have in your data set. If you don't even need a label for a specific column, you can just leave an empty text. And that way you have nice column names for all columns here. And also for stuff like Intel, Meta, or Salesforce, where it's obvious that these are company names, you didn't even put in a column label. You just left that blank via empty strings. And to make our code here a little bit nicer, let's just move this a little bit so that everything has more room. And now we can work on a bit more formatting of the numbers. You already know one formatting function, and that is fmt_markdown, but there's a whole bunch of different formatting functions for all kinds of different occasions. For example, we can still see here in the opening prices that these are just numbers, but these are dollar amounts in the real world. So it would be nice to transform this to something that looks like a currency, and similarly this relative change would be nice if it were expressed as a percentage. And for these particular scenarios, just like with the fmt markdown function, there is fmt_currency and fmt_percent. And these functions work pretty much the same as format markdown. You just pass the GT table to that function and you specify the columns that you want to target. And then you do the same thing with the percent formatting. Let me make some room here. And with that, you have nicer labels in all 4 columns. In these columns, you have dollar amounts, and in this column, you have a percentage. And this reminds me, if you find this video useful, don't forget to hit the like button, because this is a nice symbol for me that you enjoy the content that I'm creating. And speaking about content that I'm creating, if you want to master data visualization with R, you might be interested in my data visualization course, which will teach you all of the things you need to know about ggplot and the most important data visualization techniques to create charts that communicate effectively. So if you're interested in that, there's a link in the description. And now let's get back to the video. Out of the box, GT does a very decent job of aligning things in your column. You see, with text, you usually want to have things left aligned, and with numbers, you want to have things right aligned so that it's easier to compare numbers that are below each other. But just to demonstrate that you can also specifically change the alignment of any column that you want, let me just show you that you can pass your GT table to calls align, and in there target the columns that you want to change and use the align argument to set the way you want to align it. So here we could use it to center align the images, but it didn't change much here again. I've just put this in here just for you so that you know how you can align things inside of a column. Next, let us work on more text styling. And with this, I don't mean the formatting, just like we did here, but more things like making stuff larger or bold or colored. And all of these things can be done through the tab style function. As with any of the GT function, it works in a chain. So just pass your table to tab style, and in there you can specify the style and the locations that you want to style. And for both of these arguments, GT has nice helper functions to make your life as easy as possible. So with the style, there are the cell underscore functions, and you can use things like cell underscore text. And in there, if you look into the documentation of this, you see a whole bunch of arguments that can style your text according to how you want it. In this case, I just use weight bold, and I want to apply this style to the things that are inside of the company column. So inside of my locations argument, I use the cells body function, and in there, if you look into this function, you see that we can use this to target specific columns and rows inside of our table body. Of course, there are more cell function and cells with an S function, but here we can just work with these for now. If you want to see more details on that, you can check out my GT ebook. It's online for free. I will put a link to that into the description. But again, for now, we can just use these specifications, and that way we make the text of the company labels bold. So here we have done a really basic change of making things bold, but where this tab style function really shines is with conditional formatting. You see, we can use this exact strategy of setting style and locations inside of tab style to make things that are negative into red bold text and things that are positive into green bold text. Let me show you how that works. So again, we pass things to tab style, and then in the style location, just like before, we use the cell text function to set things like the red color and the bold weight. And now to use the conditional thing, you have to set the locations properly. And the nice thing about this is that you just use the cell's body function again, and then you specify columns just like you did before. But now instead of applying the style to all rows, inside of the rows argument, you use a conditional that just says use the rows where you get that the change absolute is less than 0. Here this works out pretty nicely because if the absolute change is negative, then the relative change is also negative. So this is why you can just use this as a condition to make things red and bold depending on whether the numbers that are inside of these cells here are negative. And with that, you get the negative formatting, and it helps to throw in a couple of comments into your chain to find things easier later on. And with the same logic, you can just throw in the same things for the non-negative values, set the style again with cell text and some specifications. You can use a green color instead of a red color. And then for the locations, you use cell's body again, use the same columns, but this time you target the rows where change abs is greater or equal than 0. So these will target all of these rows here. And with that, you have thrown in conditional formatting for the text in the change columns. Nice, the core part of our table is pretty much done. Now all we have to do is to throw in a bit more context. And for that, titles, subtitles, and source notes are great. And as you might guess, we can throw in all of these things through additional layers. And here we use the tab header function, and we can just specify the title and the subtitle. Once again, here you can use the MD function to use markdown notation for bold text, for example. And if you render this, it will look like this. And since you're already using markdown notation, you can also use inline span tags to modify text according to specific styles. For example, you can wrap your title into span tags, and in there you just specify the style argument that sets the font family to some other font like Merriweather. And if you execute all of this, then you'll see that the title font changed. There are some other functions available to make this thing happen without these span tags, but here it's not a lot of work to just throw this in there. So that's why I like to throw in things that way. And this is one of the ways you can be sure that it will work even if that functionality isn't implemented through some other function. And this is a technique that will be useful next week in the Python version, because in that version, not everything that GT right now has is already available in Python. So with the same trick, you can add a source node at the bottom of your table, and in there you can use markdown notation once again to throw in a data source like Yahoo Finance, and you can say that I created this table, and if you render it like this, you will see that everything is left aligned now and everything is in regular text. What you could do is also throw in a LinkedIn icon, so just throw in the text LinkedIn and wrap that into span tags, where inside of those span tags you set the font family to the Font Awesome 6 brands font family, which causes the text to render as a logo instead of the LinkedIn text. And now if you wanted to make the source node right aligned instead of left aligned, you could use a specific function within GT, but that one isn't available in Python. So let me show you one way that it works in both cases, and that is through additional HTML tags. So here we throw everything into a div container, and inside of that div container, we set the style to text align right and font weight 600, which is bold text. And that way everything becomes bold and right aligned. As you can see, I'm a fan of using these HTML tags because they are so general and work everywhere. And in case you're not so familiar with these kind of things, check out my Web Dev 4R video series where I explain these kind of web development tricks that are really useful for all kinds of R data visualizations or some other analyses that you are doing in R. Alright, sweet. We only have to apply the finishing touches to our table. So let's throw in a couple of table-wide settings, and all of these things can be done through tab options. If you look into the documentation of this function, you will see that there is a whole bunch of arguments that you can use, and a lot of the things that you see in here are things that we have already done with the HTML span tags. For example, with the headings, you could put the heading title font weight to bold, and that way you'd save the markdown notation here. I'm not sure if there's also a way to change the font family here. There's so many arguments, which is why I like to use these HTML tags, because then I don't have to worry about going through all of these arguments. I can just throw whatever I need exactly where I need it. But still, this function is nice for a couple of table-wide settings, and here I use this to change the font size for the title and for the subtitle. So if we look at title and subtitle now, we'll see that everything becomes larger. We can make this left aligned because I feel like these things, like most text, should be left aligned for nicer reading. Then we can change the font family to Source Sans Pro so that everything that isn't specifically determined through these styles here becomes Source Sans Pro. And then we can change the container width to 900 pixels to make our table narrower. And with that, we have finished our table. Great work, everyone. We have made it through this video. If you enjoyed this video, definitely check out the next video, even if you're not into Python, because it will give you a nice entry into Python, and you will see that the same logics and the same functions work in Python with the Great Tables package as well. And if you enjoyed this kind of video where we work on how to communicate things through nice tables, you will also probably enjoy my data visualization course, which shows you how to master ggplot to create not only beautiful, but also insightful and effective data visualizations that communicate effectively. So if you're interested in that, follow this link here to the course. And with that said, thank you for watching, and I will see you next time.